Most F-16s are equipped with mechanically scanned array radars, which can be retrofit with NorthropGrumman's state-of-the-art active electronically scanned array. NorthropGrumman has designed SABR for ease of installation in new production F-16 fighters and retrofit an existing F-16AB and F-16CD aircraft. SABR has been designed to ensure no airframe structural modifications, fits within defined power and cooling allocations of the F-16, and weighs less than previous mechanically scanned arrays on the F-16. Designed to be a field retrofit, upgrading to an AESA has never been more simple. The 4-line replaceable units of the existing radar are first removed. The processor, the receiver exciter, the traveling wave tube transmitter, the existing radar rack, radar cables and cable supports, waveguide and ductwork are removed. Lastly, the mechanically scanned antenna is removed. The SABR AESA installation kit contains all necessary parts. First, a new bracket is installed. The SABR radar rack comes pre-wired with the new radar cable harnesses and is installed using the existing 13 rack mounting points. Like all high-performance AESA radars, the SABR array requires liquid cooling. SABR includes its own self-contained environmental control system, or ECS, which allows the system to operate with existing cooling air allocation. The ECS includes a heat exchanger which transfers the radar's heat from the liquid to the aircraft-supplied air and is bolted to the radar rack and bracket. It connects directly to the existing aircraft ECS duct. The ECS's filter and pump for the liquid coolant are bolted onto the rack. Coolant lines are then clamped in for the SABR ECS system and new line replaceable units. The receiver exciter processor, or REP, is one of the 2-line replaceable units that make up the SABR system. The REP is of modular architecture and combines the function of the processor LRU and receiver exciter LRU. The consolidation of LRUs not only allows the addition of the ECS system while keeping within the footprint of the previous radar system, but also allows for improved performance, reliability, and fault isolation at a lighter weight. The antenna's power converter gets installed like a line replaceable unit. This unit transforms a portion of the AC power currently allocated to the mechanically scanned radar to power the new AESA array. To complete installation, the second SABR LRU, the AESA antenna, is installed. The antenna attaches to the 4 existing antenna mounting points on the aircraft. This thin, lightweight AESA antenna is highly reliable and does not move. Individual transmit-receive modules embedded in the array replace the single traveling wave tube transmitter. Typical of all NorthropGrumman AESAs, SABR's active array allows for mode interleaving and very high scan rates. SABR's air-to-air modes can detect multiple incoming aircraft and ultimately enable multiple potential air-to-air weapons launches. High-resolution synthetic aperture radar, or SAR mapping, allows accurate ground target location at long ranges for positive identification. By presenting the pilot with a big picture of the target area using SABR's SAR mode, the pilot can determine where to zoom in for greater target detail, increasing combat capability and situational awareness. NorthropGrumman's F-16 Scalable Agile Beam Radar, SABR. exceptional multi-mission capabilities supporting air-to-air, air-to-surface, and electronic warfare.